Okay, class, this is Mr. Eggleston, and these are my notes for lesson 5.2. If you're in my second and fourth period class, it was a miserable discussion that didn't do graphing these justice. It's actually not that hard. And after doing it for 2 periods yesterday and getting the same miserable result, I decided to use a CUDA software worksheet, which is just basically, here's a function, graph it. And we're going to look at graphing exponential functions. Exponential functions are of the form y equals a times b to the x. That's your basic exponential function. All right, and the best way to graph these would be to make a table. So on number 1, we would go x, y, and we will choose numbers. Let's go 0, 1, 2, 3, and go -1, -2. All right? 0's in the middle of this. That's going to be our y-intercept. So I'll make that even yellow. Okay? So let's start there. So when x is 0, it will be 4 times 2 to the 0 power. 2 to the 0 is 1. This is 1, so that's 4 times 1, which is 4. So we have a y-intercept of 0, 4. And so we have that. When x is 1, it just becomes 4 times 2 to the first, which is 4 times 2 is 8. So when x is 1, we're up here at 8. When x is 2, we're at 4 times 2 squared, and that's going to be 16. Or you could just realize we're multiplying by 2 each time. Right? We're multiplying by 2 by 2. So when x is 2, we're at 16. The next one's going to be at 32, and it's off the grid because we're multiplying by 2 each time. Okay, now it gets a little bit tougher. When x equals -1, they're asking you what is y equals 4 times 2 to the -1 power. 2 to the -1, you could just type it into your calculator. But 2 to the -1 is actually 1/2. It's a reciprocal of 2. So it's 4 times 1 over 2, which is 2. So we know that when x is -1, you get 2. Again, use a calculator if you need to. All right? When x equals -2, that'll be 4 times 2 to the -2. And if you type that into your calculator, that's 4 times... Your calculator will say 0.25 or 1 over 2 squared, or 1/4. So that's 1. Okay. When x is -3, you cut that in half. When x is -4, and you see you keep getting closer and closer to 0. You actually don't get to 0, but you get really darn close. All right. So we would just connect the dots with this kind of curve. And that's the graph. Now, on your quiz, I'm going to look for specific points. I'm going to look for the right y-intercept, 1 point to the right, 1 point to the left, and also notice this line approaches the x-axis. It will never get there, but it approaches it. So we call this the asymptote. It's the line the graph approaches but doesn't touch. And the asymptote is y equals 0. Okay? So we know that the graph will blow up to the right. So we found this point. Let's make that red. We found this point. We found 1 point to the right, 1 point to the left, and then we just made sure our graph connected those points and then had this nice curve. That's all I'm looking for. I'm also looking for this horizontal or asymptote. Okay. What's going to happen is later on this graph, on this worksheet. Like right here, we're starting to move the graphs around. So we're going to translate them and stretch it. Okay, so the next one, y equals 5 times 2 to the x. Same idea, make a table. So we would have x, y, and that's 5 times 2 to the x. We'll have, let me make 0. That's our y-intercept when x is 0. And then let's a couple numbers bigger, 1, 2, let's go 3, and then a couple numbers smaller. Okay, at 0, let's just plug it in. Again, you get 5 times 2 to the 0 power. Again, 2 to the 0 is not 0. 2 to the 0 is 1. So this equals 5 times 1, which is 5. All right, so we have a y-intercept right there at 0, 5. Now when x is 1, that becomes 5 times 2 to the first, which is 10. So when x is 1, we're at 10. When x is 2, excuse me, that's 5 times 2 squared, which is 4. So that's 5 times 4, which is 20. So when x is 2, we're up here at 20. All right, do you notice we're multiplying by 2 each time? Okay, so if you went to 3, it'd be at 40, which is well off our graph. Now going into the negative side, you got to remember negative exponents. Use your calculator. 2 to the negative 1 is actually 1/2. So that's 5 times a half, which is 2.5. So at negative 1, we're at 2.5. Okay? At negative 2, that's going to be 5 times 2 to the negative 2. That's 5, that's 5 times a fourth, which is 5/4, which is 1.25. So we're at 1.25. And what's going to go on, and I'm really only concerned about this point, that point, and this point when I look at your graphs. I want to make sure those are crossing the right points and that the rest of the graph is going to behave like an exponential, which means it's going to flatten out. And our graph is going to be like that. Notice it's going to keep flattening out as we go out to the left. All right, and it's going to approach the horizontal or the asymptote of y equals 0. So you have to know the basic behavior. And I would recommend graphing this on Desmos so you can kind of see how the behavior is. All right. Now let's talk about domain and range, okay? So for all exponentials, the domain will be all reals, all right? That's x. X is all real numbers, okay? The range, that's the y values. Notice the graph will never go below the asymptote. It'll never touch it, actually. It'll look like it touches it, and even if you graph it on Desmos, it will look like it's touching the x-axis, but it's not. It's just really, really, really close to it. All right, so the range is going to be y is greater than 0. Okay? It's above the x-axis. And that's the same for both of these. So both of these are going to be the same domain and range. Okay, so undo that. Let's copy and let's move that over here, and there we go. So this is the same too. It doesn't change. Notice it doesn't change because we're not shifting this graph up and down or left and right. Okay, so it has the same domain and range. All real numbers for the domain and the range is y is greater than 0. Now, these are both exponential growth. That's a biggie. Exponential growth. Why is it exponential growth? Because as we move to the right, you see the graph blows up. All right, we're moving along, boom, 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 boom. It goes. All of a sudden, it just takes off like gangbusters. It's growing. We call that exponential growth. They are both exponential growth. And that is because the base of this exponential is greater than 1. In other words, b equals 2 for both of these. Because b equals 2 and 2 is greater than 1 is exponential growth. Now compare that to 3 and 4. All right? Making a table for number 3, it's going to be x, y, and then we're going to put 0, 1, 2, and then negative 1, negative 2. Okay, when you put 0 in, that's 4 times 1/2 to the 0, which is 4 times 1, which is 4. So we know it crosses the y-axis at 0, 4. In other words, you're finding out the number that's multiplying, the a, if you will be the y-intercept as long as we're not shifting the graph around, up and down and left and right. All right? When x is 1, that's 4 times 1/2 to the first power, which is 1/2. Half of 4 is 2. So when x is 1, we're down here at 2. And when x is 2, that's 4 times 1/2 to the second power, which is 1/4. So that's 4 times 1/4, which is 1. Notice we are cutting in half, going down. We're dividing by 2 each time, or multiplying by 1/2 if you wish. Okay? So you could go 3 is going to be 1/2. And you could even go down here. But notice it's 1/2. Then it'll be 1/4. And then 1/8. And then 1/16. And then 1/32, which is, obviously really, really close to 0. So we're approaching 0, but we are not touching y equals 0. Okay? Now, the negative side. Well, 4 times 1/2 to the negative 1. If you use your calculator, 1/2 to the negative 1 power is actually 2, because it's the reciprocal. So that's 8. So negative 1, we're at 8. And negative 2, we're at 16. And our graph is going to go like this. Okay. And notice it looks very similar to the other 1 and 2, but whereas 1 and 2 blew up to the right, 3 and 4 are going to go down to the right. These are exponential decay. Because as x gets bigger, moving to the right, the output gets closer and closer to 0. Okay? And the domain and range and all that is still the same. The asymptote is y equals 0. The domain is still all real numbers. Matter of fact, for every exponential, the domain is all real numbers. And the range is going to be y is greater than 0. You would never get a range such that y is less than 0 unless it's reflected, unless it's upside down. Okay? Now, but this is decay. Notice it gets smaller as we move to the right. Right? We start up here and we're going down, down, down. And we bend to follow that asymptote. All right, 2 times 1/2 to the x, same idea. X, y. We'll again choose negative 2, negative 1, 0, 1, 2. And heck, if you wanted 3, but I don't think it's going to work too well for us. All right, when x is 0, it's 2 times 1/2 to the 0 power, which is 2. Again, 1/2 to the 0 is 1. When x is 1, that's 2 times a half, which equals 1. So we start here at the y-axis at 2, then we're at 1. We're at 1. Notice we cut the distance in half. At 2, it's going to be a half. At 3, it's going to be a quarter. At 4, it'll be an eighth, and so forth. So we're getting closer and closer to the x-axis. Okay. And then when we go to -1, that's going to be 2 times a half to the -1, which equals 2 times 2, because we reciprocate. It's 1 over 1/2, which is 2, and that's 4. So when x is 1, we're at 4. When x is at -2, we'll double 4 and we'll be at 8. And when x is -3, we'll double 8 and be at 16. And when x is -4, we'll double 16 and be at 32, which is well off the graph. And our graph looks like this. Notice the difference in shapes, right? They look very similar to each other. That is the green and the white. But the top, the green, is exponential growth because it's blowing up. That's exponential growth. This is exponential decay because it's getting smaller moving to the right. And notice the only difference, if you look at this really, is the base. Notice the difference in the base. For growth, the base is greater than 1. For decay, the base will be less than 1 because we're repeatedly multiplying by a number less than 1. So the product's going to get smaller and smaller. Now, on 5 and 6, we are now going to start shifting it around. Okay? First off, whenever they ask you to graph an exponential equation, always look to see if there is a number being added at the back end, like on these two cases, because that will be the horizontal asymptote. So we know the horizontal asymptote, which HA, is going to be y equals 2. So what that means is whenever you graph these, put down a dashed line at y equals 2. This is your horizontal asymptote. It'll help you graph these. Because you know, and we know that since b is greater than 1, it's going to be growth. So it's going to look like that. It's going to blow up to the right and flatten out to the left. All right? So, and it's also growth because b, the base, is greater than 1. Okay. Now let's plug in. Let's plug in x equals 0. And when we do, And when we do that, we get, this is the y-intercept. This is going to be 3 times 2 to the -2 plus 2. Okay. All right. All I'm doing is plugging it into this equation here. This gets a little bit tricky. All right. 2 to the -2 is 1 over 2 squared, is 1/4, so that's 3 times a fourth plus 2. All right. So 3/4 plus 2 is 2 3/4. So our y-intercept is at 2 3/4, which you estimate to be about there. That one's a little bit tricky. And then when x equals 1, that will be 3 times, so that at x equals 1, that will be 3 times 2 to the -1. All I'm doing is plugging it into this equation here, plus 2. So that's going to be 3 times a half, because 2 to the -1 is a half. That's 3 halves, plus 2. 3 halves is 1.5 plus 2 is 3.5. Okay. So it's at, when x equals 1, we're at 3.5. All right, and we're there. When x equals, when x equals 2, notice when x equals 2, we get 3 times 2 to the 0. We plug it in, plus 2. That equals 5. So when x is 2, we're at 5. And now you get a gist of how this graph looks. Now it looks something like that. Oh. Okay. Domain is all real numbers. The range is y is greater than, oh, not 0. Y is greater than 2 because that's the horizontal asymptote or the asymptote. And there you go. Okay. Notice this is growth. It blows up. Why? Because b, the base, is greater than 1. Okay. Now to do number 6, we're going to do the same thing. We are going to make a table. Always look at the horizontal shift. Always look at what's going on here. You want to center your table around the number that makes the exponent 0. So x minus 1, that means this is going to be centered around x equals 1. So we're going to choose a couple numbers larger and a couple numbers smaller. Again, I'm looking at the exponent because I want this exponent to be centered around 0. And so we figure out what the x value is that makes that happen. Okay, so if we make it centered around 1, this will be my centering point, if you will. And then our equation becomes y equals 4 1/2 to the 0 power, if we put 1 in, minus 2. 1/2 to the 0 is 1, so 4 minus 2 is 2. So we know when x is 1, we're at 2. And that's my quote-unquote centering power. Okay, centering value. Now when x equals 2, that'll be 4 times 1/2. 2 minus 1 is 1, so it's 4 times 1/2 to the first, which is 1/2. Minus 2, which equals 0. So we know when x equals 2, the graph is going to have an x-intercept at 0. When x equals 3, that would be 4 times 1/2 squared minus 2. Again, why is it squared? Because it's x minus 1. So that's 4, 1/2 squared is 1/4, so that's 4 times 1/4 minus 2 is going to be 1 minus 2, which is -1. So when x is 3, we're at -1. All right? And that's really all you need because, well, we could go to 0, and that would be 4 times 1/2 to the 0 minus 1 to the -1 power minus 2. Negative 1 power means you reciprocate, and 1/2 to the negative 1 is 2. 4 times 2 is 8. This equals 8 minus 2, which is 6. So we're there. That's the actual y-intercept, is at 6. And then you could just see how the graph is going. Okay. The horizontal asymptote is going to be at y equals negative 2. Why? Because it's always going to be whatever number's being added or subtracted at the back end. If there's nothing being added or subtracted, then the asymptote's at 0. So the horizontal asymptote's y equals negative 2. The y-intercept, which is 0, comma, the y-intercept is at x equals 1, or no, it's not. If x is 0, we get 6. So the y-intercept is 0, comma 6. Okay? And so, and it's decay, because b is less than 1. This is decay, which means you are expecting the graph to do this, flatten out like that. Whereas, since b was greater than 1, the yellow graph is you should have expected to do that. It flattens out to the left and blows up to the right. Okay, don't worry about this because I'm not going to ask you to do that. By the way, the horizontal asymptote here is y equals negative 2, and the horizontal asymptote on this one is y equals positive 1. Okay? So just to let you know, and again, that would imply that your equation would be y equals a times b to the x minus 2. We just have to you would have to figure out what a and b are, which is not that tough, but we're not going to do that. And this one would be y equals a times b to the x plus 1. Okay? Now, I gave you the graph solutions here, so you can see what the solutions are. All right? So the learning targets. We learned how to graph exponential functions and identify the y-intercept and asymptote. We learned how to identify the domain, which will always be for these, all real numbers, and the range, which is going to be for this, y is greater than whatever the k value is. Know if modeling growth, that means the base b is greater than 1, or decay, which means the base b is less than 1. And write equations for transformed exponential equations. All right? So general exponential function is this. Write this down, or it's on your paper. Make sure you understand this. A is the y-intercept if there is no shift, if h and k are 0. So that a would be the y-intercept. The horizontal shift is holding hands with the x. X minus h equals shift right, h units. X plus h, shift left, h units. Okay? The domain for any of these is all real numbers, and the range is going to be y is greater than k if there is no reflection across the x-axis. Okay? That is if A is positive and not negative. If A is negative, it's reflected. And then the range would be the reverse of this. Y is less than K. All right? I hope that helps. And I'm sorry, second and fourth period, but that's pretty much all you need to get from that whole discussion from yesterday. So have a good day.